So now we start solving the problems of ODE from year 2020. ODE 2020. So there are all around, I think there are 6 questions altogether, and we will be solving all of them one by one. The first question is differential equation. This, given is, we write the equation like, you see there is some pattern over there, like y by x, x dy, y dx. There are two methods which can be utilized to solve this problem. Like first one would be like dy by dx, something in numerator, something in denominator. But if you will do like it can be solved by that approach also. But if you observe this expression very it's very accurately, very in order to find out what are the hidden clues available to solve this problem, you will find that like cos x is y by x, y dx x dy, like something like exact kind of format is there. Even if we are not able to see there is exact in this question, we will be able to solve by changing this question in this format, like dy by dx equal to something in numerator and something in denominator, and you will find that it will be an homogeneous equation. Basically, homogeneous basically the same. You can substitute y is equals to v of x, and it can be solved easily. So homogeneous basically means numerator and denominator has each term of same degree. Homogeneous can be done. Homogeneous equation. I had done this, so I am able to tell you this. It can be solved via this method also. Y is equal to vx, but it will be lengthy. You must have a kind of sense that you must have kind of gut feeling that something can be done with respect to exact also. This was method 1. Method 2 would be exact equations. So what we do is that, see, this is x dy y dx, x cos yx dxy. You see, this is, we can make it format of y dy by dx. Why we are making this format, that something is given in sine y by x. Since the sine something is of the format of dy by dx, sorry, d of y by x, we are trying to make this whole expression into this. So what we can do is that multiply by x square downstairs. So what we can do is that x square above and y sine y by x and then x dy minus y dx x square. This becomes dy by d of y by x. So eliminating this, cos y by x d of xy, y xy sin y by x dy by x. You will realize that now we can integrate it with respect to d of y by x. So what we can do is that, like, bring this to the RHS side. You will find that d of xy upon xy is equals to tan y by x, d of y by x. Now integrate both sides. how we did this, like we observed like what kind of format is given, and we try to make the exact equation. We can, this problem can be done by other method also, like I discussed, but if you are able to analyze this thing, your task will be much easier. 10x ln mod sec x plus c. So this can be written as xy uh, ln cos x sec cos y by x. Then it can be something e raised to the power c, that is nothing but another constant. So this is our final equation. So the theme was you identify the exact equation. How will you be able to do this? By practice. Find orthogonal trajectory of family of circle passing through the point 0, 2, 0, minus 2. Since I didn't took a screenshot of this question and had put this in the PDF, that's why I wrote this problem here only. So nothing. This is a simple question, and a pattern can be followed in order to solve such kind of problem. What you can do is that just create differential equation and try to replace create differential equation and replace y dash with respect to minus of, create differential equation and replace y dash with minus of 1 by y dash. So a general equation of circle is x square y square 2gx 2fy plus c. Since it passed through 0, 2, then it can be written as 4. Then after 2gx, sorry, this becomes 0, this becomes 0. 4y plus c pass through 0 minus 2. Then it becomes minus 4y minus fy, sorry, plus c. Add both of them, adding them, c comes out to be minus 4, and if we put c here, it will be only f. So you will be getting f equals to 0. So we have got equation as, now equation x square y square 2gx f is 0 and 4. Then now we have only one variable, z is a variable. Now we try to differentiate it and will eliminate the variable to get a differential equation. Differentiate with respect to x. 2x 2y y dash 2z equals to 0. So you can do is that you can put this 2g, then 2z becomes minus of 2x 2y y dash 1 2, put 2 in 1, we get x square y square x minus 2x minus 2y y dash Fine. Square y square 2xy dash minus 4 equals to 0. Fine. Now we are replace y dash with respect to minus of y dash. And it's become this will become y square minus x square sorry 2xy y dash minus 4 equals to 0. I think we are done. So y square minus x square y dash minus 4y dash plus 2xy, so 0. What is y square minus x square minus 4 plus 2xy. Now dy by dx y square minus x square minus 4 2xy dx. Fine. This becomes mdx and dy equals to 0. Here m is 2xy and is y square minus x square minus 4 equals to 0. Sorry, not 0. Now when I do del m by del y, it is 2x, and del n by del x, it is minus 2x. So why we are doing so? Because we analyze that it cannot be solved through homogeneous equation. Like even if we put all this in form of dy by dx into something like numerator and something in denominator, a homogeneous equation cannot be formed. And if the homogeneous equation has not been formed, we cannot put y equals to vx. So that method is totally not applicable in this case. So what we did here is that we try to convert the equation into m dx and dy kind of format, and we realize that something we are getting. Fine. So a very it's also very general equation to solve a differential equation. Like if both of them becomes equal, then it might have become exact and we could have applied the exact formula. But another form is there, like even if like kind of like del m by del y minus del n by del l by 1 by n is of equal, is a function of n here, so it will be of n is associated with y, then it should be a function of x. So if we do this, then it will become 1 by 2n. N would be no. We put it as m then rather. Then it will become function of x. Yeah, 2xy, then it should be n also, n only. Like basically it will get reversed, like plus minus. then it would be something like minus 2x minus 2x, then it becomes 2 by y minus, which is a function of f of y. It should be of, since we are multiplying with m here, therefore it should be associated with, therefore it should be f of y, and we have got f of y. So now we could proceed further. Now integrating factor is nothing but integration of f of y if we do this, it comes out to be e minus of ln y then it becomes minus 1 y square. So multiplying both sides by this 1 upon y square, we get as 2x by y dx 1 minus x square y square minus 4 by y square dy is equals to 0. Fine. Now we can solve the working rule, like working rule for exact equation, like we integrating here, we just do, we keep y constant, so it would be x square plus y, x square by y, and integrating n dy term, we will be eliminating, we will be removing x term, so it will become y minus 4 by y plus c. I did directly, so this is the final solution. You can see how a working rule for solving exact equation. What we do is that we keep y constant while integrating the dx term, and we will remove this term because it contains the x term, and while integrating n dy term, we will be removing this term, so it will become y and integrating this 4 by y. So this is the final solution of this equation. So identifying that, we will be identifying, like solving the ODE, and it was not that difficult task. The task was that you need to identify that we have to apply this this kind of function. So rest is easy. So coming to the third question, that is 6a. Using the method of variation of parameters, solve the differential equation. So what we used to do in method of variation of parameters, first we used to find complementary function, then we find particular solution, and the total addition of both of these will yield a complete solution. So we know that let complementary solution be uv, where u is given as e raised to the power minus x, then v is given by d2v dx square plus p u 2 by u du by dx dv by dx. Yeah, I think it is all right. Yeah, what we'll be doing, that d2v by dx square plus p is nothing but this term. When and you should be careful while taking up p here. You need to make this equation into a standard form. Here it is given in standard form. Many times this equation is not in the standard form. First task would be to make this in a standard form and then solve. So p by comparison comes out to be 1 minus cot x. Fine. 2 by u is what? u is e minus x by minus 1. So this get cancelled, dv by dx. So if we do complete this, dv by dx square minus 2 1 plus cot x dv by dx. Say dv by dx equals to p. We have to solve this equation, so it will become dv by dx square 1 plus cot x p. So it will become dv by p, and if we integrate this 1 plus cot x dx, integrate this will become ln p. Then it will become x. Cot x is nothing but ln mod, I think it is ln mod sin x, I think, yeah. Tan x integration is ln mod sec x, cot x is ln mod sin x. Then p is, there will be c also, because we are integrating, there will be constant also. Many times we used to forget this, so we need to be careful. So p comes out to be c e raised to the power x sin x. So dv by dx is nothing but c e raised to the power x dx sin x dx. We took the dx there. Now we'll be integrating this. It will come out to be v is c. See how we will be integrating this. Whenever such type of expressions comes into integration, you do a separate kind of calculation. Like, see what I'm doing. Take it as I is nothing but integration of I e ki power x e raised to the power x sin x dx. If you will integrate by parts, integration by parts, take it as first function, this is a second function. So sin x e ki power x, sin x differentiation cos x e ki power x dx. Again integrate sin x e ki power x minus again take it as second function, it is as first function cos x e ki power x. Cos x differentiation is sin x minus sin x e ki power x dx. And you will realize this is nothing but I. This then minus of I. Why we did so? Because it will keep on recurring kind of expression. So we just put it as I, and it will come here in the LHS side, and it will become ex by 2 sin x cos x. We have learned this method into our class 12th, where we have learned how to solve these kind of integral equations. So this is the final equation of integration. So we will become, now coming from this equation only, we will become ex c ex by 2 sin x cos x, sin x minus cos x plus c2. There will be another constant because we are doing integration again. Say c1 by 2 as another variable, c1 at e raised to the power x sin x minus cos x plus c2. Now what will we do is like y complementary is nothing but uv we know as e raised to the power minus x, c1 sin x minus cos x plus c2 e raised to the power minus x. So we got our complementary function. Now by method of variation of parameters, y particular will be in place of constant, there will be some x function, sin x minus cos x plus bx e raised to the power minus x. Fine. How will we finding ax and bx? Using Wronskian. Always I used to pronunciate this term. So we'll be using Wronskian approach. So Wronskian W as is nothing but u dash v dash is nothing but sin x minus cos x. U is here. This is u. This is v. Sorry, this is u. This is v. By convention, like we have already taken u as minus e by x, e raised to the power minus x as u. Even if there was no issue, but we should go with flow. E raised to the power minus x, sin x minus cos x, e raised to the power minus x minus sin cos, sin difference between cos sin. So what we get here is e की power minus x cos x plus sin x plus sin x minus cos x. Two sin x e की power minus x. I think this is. I think we are done with function. Yeah. So how will be finding ax as nothing but ax will be I used to do this. Ax will be minus u r by w, and bx will be v r by w. Ax would be nothing. Ax is nothing but u is nothing. U is what? E की power minus x power minus x r was sin square sin square x by by 2 sin x e की power minus x. E की power minus x cancel, sin x cancelled, and ax is by convention. This should be I don't think like there should be any problem. Let's see. I have some confusion over here, but let's see what the final answer comes. I think there should be no any difference here. Minus half sin x is cos x. B is what? V is what? V is sin x minus cos x. R is what? Sin square. Then W is 2 sin x e की power minus x. Now we have to do again manipulation here. e की power x sin square x minus cos x sin x dx. Now taking this side, b is nothing but half of e की power x. We have to solve this. Sin square x, we can write this as cos, in terms of cos 2x is 1 minus cos square minus sin 1 minus 2 sin square. So sin square x is nothing but 1 minus cos 2x by 2. Half minus cos 2x by 2. I think we are correct. E की power x cos x sin x. It has become tedious here. B is equals to half e की power x by 2 fine minus e की power x cos 2x by 2 then after e की power x cos x sin x. I hope we are correct. We have not done any calculation error. Yeah, I think so. Again, it will become half. This will be as it is. Fine. Okay. Fine. Let's multiply this with 2 here. Minus e की power x cos 2x by 2 minus e की power x sin it was sin 2 theta. Like multiply 2 and 2 in numerator, 2 in denominator, it will become sin 2 theta. Sin 2 theta, sin 2x by 2. Yeah, that's fine, I think. Then it's become e की power 4 e raised to power x by 4 minus half of, and now we need to manipulate. If we take half outside, it will become 1 by 4 here also. We need to manipulate e की power x cos 2x minus integration of e की power x sin 2x. Again, we will be proceeding by this approach only. We have to assume I as I equals to the entire integral, and something recurring term will be reassigned as I, and we will get final solution. So actually I have already done this, so I am just putting them. What you can do that, you can try on your own. E की power it was I think around e की power x by 5 cos 2x Yeah, hopefully we have not done calculation error. 2 cos 2 sine 2x e की power x by 5 sine 2x minus 2 cos 2x e की power 4 e की power x by 4 by divided 4 minus 1 by 4 e की power 5 I think sine 2x sine 3 sine 2x minus 2 plus 1 minus cos 2x. This is b. Then y particular is nothing but ax plus a of x. This is b of x. This is a of x. A of x u. A of x sine x minus cos x plus b of x is b of x into e की power minus x. I think we are not wrong. Yeah. So a of x is nothing but half of cos of x. Sin x minus cos x. Bx is nothing but this entire term. So if we multiply it with respect to with my e raised to the power minus x, this will cancelled. This will basically will become e raised to the power 0, which is nothing but 1 minus 1 by 20 1 by 23 sin 2x plus cos 2x by 20. Yeah, I hope everything is good. So now this is final YP. We can simplify it further or we can let it as it is. No issue with respect to that. Then YC is nothing but YC plus YP. YC we already know. YC was C1 sin x minus cos x plus C2 e की power minus x. YP is nothing but this वाला term, half of cos x sin x. We can leave it as it is. I think there should be no issue. Cos x sin x. If you multiply to numerator and denominator, it will become sin 2x. Then it will become sin 2x by 2, sin 2x by 4 minus cos square x by 2 if we multiply, if we will be doing it 1 by plus 1 by 4 minus 3 by 20 sin x sin 2x cos 2x by 20. So what we can do is that we can club them together. C1 sin minus cos x plus C2 e की power minus x plus sin 2x is nothing but 2 by 20, I guess. Yeah, plus 1 by 4. Even that can be written as cos 2x can be written as cos 2 theta, cos 2x minus cos square minus 2 cos square minus 1. Then will become cos square is nothing but cos square x is nothing but 1 plus cos 2x was 1 cos 2x by 2 So it will be minus 1 by 4 1 plus cos 2x by 20. Yeah, this will get cancelled. C1 sin x minus cos x plus C2 e की power minus x plus sin 2x 1 by 10. Sorry. Then will become 1 by 4. It was, I think it was, no. That should be entirely divided by 2. No, we are correct. Plus cos 2x 1 by 4 5 minus 1 4 by 10 by 20. Sorry, this will become 2 by 20. 2 by 10 1 by 5 2 by 1 by 5. So we got the final solution. This is our final solution by doing all the simplification on our. That's all.